Watch what happens when sunlight shines light through water. Wow, oh my god, a rainbow. But how exactly did that happen? Okay, but before that, what exactly is a rainbow? Scientifically, a rainbow is an optical phenomenon appearing as a multicolored arc in the sky, caused by a reflection, refraction, and dispersion of sunlight that splits into its spectrum of colors, which is red, orange, yellow, green, blue, indigo, and violet. But basically, a rainbow is just sunlight with different colors.
The primary light source in a rainbow phenomenon is sunlight. For a rainbow to be visible, the sun must be behind the observer, typically at a low altitude, while water droplets such as rain, mist, or spray are in front of them.
The sunlight we see is classified as white light. Although it's called as white light, it is actually made up of spectrums of different colors combined to one, and each of these colors have different wavelengths.
A rainbow forms when sunlight hits a certain droplet of water. Water has a higher refractive index than air, which means light travels slower in air and bends when it enters. This process is known as refraction. The different wavelengths cause sunlight to split into its component colors by dispersion. As the sunlight hits the back of the droplet, and if the angle of incidence is large enough, the light will be internally reflected back out the droplet. And as the light exits the droplet, it speeds up, further dispersing the colors.
There are two types of rainbows, a primary and a secondary rainbow. Primary rainbows are bright inner arcs formed by one internal reflection of sunlight and raindrops, displaying red on the outer edge and violet inside. Secondary rainbows are fainter outer arcs caused by two internal reflections, resulting in reversed color order, violet on the outside, red on the inside, and a wider angle.
There is actually a reason to why primary rainbows show red on the outer edge and a violet blue on the inside arc. This is because the wavelength in a violet blue is shorter, causing it to change angles more than the red one with a longer wavelength.
The secondary rainbow forms when the light is reflected twice inside the droplet, resulting in an order of its colors being reversed.
So, now that you already know, let me ask you a question again. How are rainbows actually formed?